All right, let's add a new class. We call it weighted graph. Now, to save time, I'm going to borrow some code from our existing graph implementation. So over here, first I'm going to copy the code for the node class. So copy and paste it over here. So far, so good. Now we need to implement the edge class. So private class edge. Here we need three fields, from and to. These are both node objects. So private node from and to. We also need the weight. So private integer weight. Now I'm going to create a constructor to easily initialize an edge object. So let's generate that real quick. I'm going through this super fast because you have seen several examples of me doing this throughout this course. If you think I'm going too fast, then you probably have to go back and start from the beginning. So here we have a constructor. It's also good to override the toString method, especially if you're going to debug this program. We can easily see the output of an edge object in the debugger. So let's generate a toString method. Now I'm going to simplify this expression and only return from plus this arrow and to. With this, we're going to get something like this. A goes to B. Pretty useful. So we're done with the edge class. Now, back to our graph implementation. Here we have two hash tables, one to store the nodes, one to store the adjacency list. In this implementation, we are mapping a node to a list of nodes. But in our new implementation, we should map a node to a list of edges because each node can have multiple edges. So back to the weighted graph. Let's add these hash tables real quick. So private map of string and node. Let's import the map. We call this nodes and set it to a new hash map. Next, we're going to create a map of node to a list of edge. We're going to call this adjacency list, just like before, and set it to a new hash map. We're almost done. Now, finally, we need to implement two operations, add node and add edge. So I'm going to bring these two methods, as well as the print method for verifying our graph, into our new implementation. Now, we have a few compilation errors, but they're really easy to fix. So as we pasted this code, IntelliJ thought we are referencing the node class inside the graph class. But as you know, this class is private. We cannot access it. But here we don't care about the node class inside the graph class. We want to work with the node class we have defined here. So let's remove this prefix. There it's gone. So this is how we add a node just like before. Now let's work on the add edge method. Here we need to add a third parameter. That is the weight. Now, just like before, we validate the from and to arguments. If they are valid, we go to our adjacency list. We get the entry for the from node, which is a list of edges, and then we should add a new edge to it. That is why we have a compilation error, because we're trying to add a node object to a list of edges. So here we need to add a new edge object. As the first argument, we should pass the from node, then the to node, and finally the weight. Now let me put this on a new line so you can see all the code in one place. So this is how we add an edge. Now earlier I told you to implement this class as an undirected graph. So when we add an edge from A to B, we should also add an edge from B to A. That is super easy. So we go to our adjacency list, get the entry for the to node. This will return a list of edges. Then we'll add a new edge. So a new edge. Our arguments are to node, from node, and weight. Okay. Now we have a weighted undirected graph. Let's test our implementation. So I'm going to go to the main class and create a new graph, a new weighted graph. We give it 3 nodes. Let's say A, followed by B and C. We also add an edge from A to B with the weight of 3, and one from A to C with the weight of 2. Finally, we call graph.print and run our program. So, as you can see, A is connected to B and C. Now, because we have an undirected graph, here we have two inverse relationships. So B to A is the inverse of A to B, and C to A is the inverse of A to C. This is a weighted undirected graph.